Hi everyone, today we're doing example 5A13 from the dynamics textbook, and it says given the thin homogeneous bar AB having a mass of m equals 30 kilograms and length L equals 4 meters is released from rest at the position shown where theta equals 36.87 degrees. Assume all surfaces to be smooth. Determine the angular acceleration of the bar on release.
So we're in on the board, we have our given values and then also our given picture. So our first step would be doing a free body diagram, and we have three forces on it. So first we did our gravity, which is acting on the sector. And then we also have two normal forces because we have two different surfaces. So at the first surface A, we have a normal force 1 going up. And then at surface B, we have a normal force 2 going in the negative x direction. So then step 2 would be determining our coordinate system. So we chose Cartesian for that, which is shown here. And then step 3 would be writing our forces in scalar form. So for our gravity, we have that equal to negative mass times gravity in the j direction. And then for our normal force 1, we have that equal to mass times gravity in the j direction. Our normal force 2 is equal to negative mass times gravity in the I direction.
And then step 4, we have the acceleration equation, and that is AG equals AGX in the I direction plus AGY in the J direction. And then for step 5, we're gonna sum all of our forces and set it equal to mass times acceleration AG. So all of our forces from step 3 will be added here. So when you do that, you have negative mgj plus mgj minus mgi hat equals agx I hat plus agy j hat. Then you're going to separate those and create scalar equations. So in the I direction, you're going to have negative mg equals agx. And then in the j direction, you're going to have negative mg plus mg equals agy. And then we're going to come over here to step 6. Step 6 is finding the moment about a point on our rigid body. So we did moment about g, which is the center of gyration. Therefore, we could use special case number 1. So we have the moment, sum of all the moments about g equals ig times acceleration, or alpha. And then, so you're going to take your forces that act upon that point and then multiply it by the distance it is from the center of gyration. So when you do that, you have n1 times L over 2 sine theta minus n2 times L over 2 cosine theta equals Ig alpha. So then if you go to page 303 in the textbook, Ig a thin stick is Ig equals 112 mL squared. So we just use that and plug it in over here. And then we only have one unknown in this equation. So we just solve for alpha. And once you plug in all of our values that were given, you get alpha equals negative 2.943 radians per second.